My style is whatever coffee is available if I'm tired and I need to be awake.
Curtis, thank you so much for joining us. This is an episode we've been waiting to do for a while, and we're very excited to have you join us on the MLOps podcast.
Thanks. Yeah. Glad to be here.
You know, I think the first place I want to start, and Dimitrios, I want to get you going on this too, because I know you have a lot of thoughts on data-centric AI, is, I know you got a lot of thoughts. My first question is, what is the difference between MLOps and data-centric AI? Like, just starting right there, like, what is the difference between those two terms, just so we can start this conversation from a clear point?
Yeah. Well, I think the terms are still being, made up. But I'll give you my take and based a lot on where we are today, Cleanlab. So I think of ML ops is what you expect, anything that's in ML operations. And that can involve the model, right? Because in ML, you have both the model and the data. So I think of ML ops as a superset. Also, data-centric AI is kind of a different thing. ML ops is more of like an industry standard type term. There's some papers in academia now that'll reference ML ops. And I think there was just a paper that came out that was like, here's, the landscape of ML ops. But that's kind of new in the academic realm. Most of data-centric AI is going to be more on the academic realm and industry. And I think that's because folks like Andrew Ng are pushing it, and they're both in academia and industry. But in ML ops, it's like more industry pushing it. So you're going to get different flavors there. Another big thing in data-centric AI that's yet to be done, but speaking more to the future, because I think the future will determine how these two terms separate themselves out, is in data-centric AI, there's a lot of work yet to be done to show theoretically why is using data in some circumstances and focusing on improving data actually a more effective solution for approaching some machine learning problems. And I'm happy to chat more about that. But one example that may surprise people is that you can actually show for doing machine learning with noisy data and noisy labels, you can actually show that several methods that work by altering the data but not the model actually outperform methods where you alter the model. And happy to chat more about that. But there's a bunch of, I would think of just data-centric AI as more of how do you fix up the data in order to improve the AI pipeline? And then ML ops is you can do anything. You can change the model, you can have better infrastructure, better parallelization, et cetera.
That's definitely the clearest answer I've gotten to date. What do you think, Dimitrios?
How am I supposed to follow that one? That was so good. I was just going to talk some shit on people saying like, oh, well, data-centric AI, it's the new marketing buzzword that you hear all about because people want to talk about how it falls in line with this idea of data scientists spend too much time cleaning their data. They need to look at the data more. We need to focus on our data more. And for me, data-centric AI is just one of those things that is more of a buzzword. But when I hear Curtis say that, I'm like, yeah, I go along with data-centric AI now. All right.
Yeah.
I can get down with that. It sounds really good when you put it like that.
What I like about what you just said there, Curtis, is I think this idea of data-centric AI is really, to really plagiarize your words, is about how data solves machine learning problems, right? Not just thinking of it as like an incidental sort of component of a machine learning pipeline, which has been the way that I think a lot of work, maybe from like 2015 to 2020, really thought about data. But now thinking about it as like very much a starting point for the solution. And, that has coincided with, in the MLOps world, a lot of attention to data pipelining, how to set up data pipelines, and how to set them up in a way that, kind of respects the quality of data and focuses on that. And so starting with that point, what I'd like to ask is, how did you realize this problem of data quality in machine learning manifesting? What was your personal experience or your war story that made you want to get into this realm around data quality?
Yeah, for sure. A quick tidbit on your first comment, and just one way for folks who are new to data-centric AI to think about the field and how to think about how do I get started? Like, what is data-centric AI? What are we even talking about? Just to get started, you can just think about something really simple like k-nearest neighbors. So if you're from the ML space, if you've ever done k-nearest neighbors, that's really just data-centric AI. I mean, there's no actual like big model, right? I mean, you have to store some representation of distances between to make things more efficient, but you could also not. You could literally just have a data set and that's all you've got. And then you have some new point and you're just like, what's the data near me? what's the label of that? Predict that. And that's like a very data-centric approach. So just to sort of help ground, how you can think about how the two are similar and different.
And
With that in mind,
one thing to
yeah.
like jump in real fast is with data-centric AI, for some reason in my head, it was always associated with like computer vision problems. Am I the only one who thinks that, or is that something that is precedent? Like, is it not more a computer vision thing, or does data-centric AI cover all of it? Because I guess it does, and especially the way that you're explaining it, it totally does.
Yeah, it covers all of data. If it's
Yeah.
data, it can fit in data-centric AI. And one way,
It's under the umbrella of the data.
yeah,
Okay. Don't let me derail you from Vishnu's great question with my ridiculous ones. Go ahead.
yeah. I'll say one thing and then maybe just a reminder of the question, both for myself and for the audience. But the sort of one final important way to think, I think, at least for me, what helps me is there is no learning without some way to learn and something to learn. So there is no machine learning without both a model and data. There is no human learning without, a brain and some information to learn from. So all learning exists in the context of both a learning model and also data. And so that the both fields are going to be highly important to the field of machine learning.
I think we just got our quote, Demetrios. There's the quote for this episode. You're already coming in hot, Curtis. There's no way to learn without something to learn and some way to learn. And I think that's a great summary of what we do in machine learning overall, is really think about those two pieces. To go back to my question, it was really about what experience or war story got you into this field of data quality testing and data-centric AI. What was it that made you want to focus more on that?
Yeah, you bet. So from the beginning, this immediate short answer is I built the cheating detection system for MIT and Harvard. In particular for their online courses. You can look it up. It's called the Cameo, CAMEO, Cameo Cheating Detection System. And we observed something. And what we observed was that people on edX courses were creating multiple accounts. And on one account, they were just clicking show answer. And then on another account, they were clicking, submit answer. And they were doing it on these two accounts with the same IP address within like 3 minutes of each other, sometimes within 3 seconds of each other. And they were doing it over and over and over and earning certificates. And so when I first started at MIT, I'll rewind. How did we get there? So why was I building that? Why is that? Who cares? So I'm from rural Kentucky. I grew up in Kentucky. My dad was a mailman. His dad was a mailman. His dad was a mailman. So if I had been, a mailman, I would be a 4th generation mailman. My mom she works in a call center, and don't imagine like a big farm. Imagine, what you might expect from rural Kentucky, small stone house with its problems and all that. And so this is sort of how I grew up, and there wasn't a lot of opportunity. But one way that I created a lot of opportunity in the US was we have the best educational system. At least, how should I know? I didn't grow up anywhere else, right? But I thought it was awesome because I have a really nice life today, and I didn't when I was growing up. And the way I did that was just to do well in school. So just imagine that motivation. That's where I'm coming from, okay? And now I finally get to MIT, and it's been, this big, exciting journey getting there. And every day was better than the day before, and there's always more opportunity. It's getting more and more exciting. And finally, I know what I'm going to do for my Ph.D. I'm going to use machine learning and AI to help people in education, and most importantly, to democratize education, to make it available to everyone in the world by being the first researcher at edX. And that's what I was. So I was at MIT, and I was working with Isaac Chuang and Sanjay Sarma. He's the vice president of open learning at MIT. And Isaac Chuang was the senior associate director of edX and open learning. And so I'm working with these guys, and how do we make certificates? How do we first get them to be accepted by the world, so everybody in the world can, get an education from MIT or Harvard, even if you're from, some small place in Africa, as long as you have an internet connection. So that was the goal. And then you find out, you make a discovery. You're going through all the tracking logs of, literally millions of students, and you find that people are just cheating to get these certificates. And then you find out that they're taking a certificate that they cheated on, and it says now that they have 7 certificates from MIT, and they go and they get a job. and then they can't do the job because they cheated to earn the certificates. And now someone else who's from where I'm from, say from rural Kentucky, or say from some poor place in Africa, they apply for the same job 6 months later, and they don't get it. And they don't get it because even though they actually earned those 7 certificates, someone else cheated and ruined it for them. And that to me was like the worst thing ever. Like, think about my background and how much opportunity means to me. And we're trying to create this. And now you just ruin that for someone. And so I was very, very motivated to solve this problem of cheating detection. Now, what does that have to do with your question? What it has to do with your question is that cheating detection is literally just a noisy label. It's literally just an error in data. If you think about data as you have a bunch of certificates, the question is, which of those certificates are the errors? Which of those certificates are the ones where someone cheated? So first, I wrote some very simple pipelines, like filters, like I mentioned, same IP address, a bunch of filters to get data, right? But my data was noisy. I missed people, and I had lots of false negatives, people I just didn't get because I had very tight thresholds. We don't want to accuse someone of cheating if they didn't cheat, right? That's a very bad thing. So I had to have tons of false negatives, people who I just wasn't catching. So then I was like, okay, how do we solve this? So, well, I was a PhD student in machine learning, so I'm going to try to take AI and machine learning approaches. And at this time, it was 2014, and there was no multi-class solution for machine learning and with noisy labels. It just didn't exist. And so I started applying machine learning algorithms and training them on this noisy data, and nothing worked. And there literally wasn't a solution. And so this was very frustrating because I had this problem I'm very motivated to solve, and I've shared why. It's really important for the world, and I just can't solve it with machine learning. And a sudden, I had a big realization, and the realization was, if you want to actually train AI machine learning models on really messy, noisy labeled data, especially for human-centric problems where you really want to help people, and it's for people, people's data is messy, and people's data is really noisy. And so we needed a framework in machine learning to be able to deal with messy and noisy data. And I spent the next 6 years doing it. And I can share more about what we did at various companies, like Google and Amazon along the way before Cleanlab existed.
Yes, please. That was what a story, man.
Yeah, I know, right?
Bringing it all the way from Kentucky to
Yeah.
edX to now like what Google and Amazon are doing. I love that. Like, keep it coming. I'm just gonna sit here and listen.
You bet.
I really appreciate you taking us through your story there. The one, Demetrius, what this kind of reminds me of is Cody Coleman's episode that we did like a couple months ago. It's like very similar in the sense that you guys have these amazing personal stories that you've channeled into motivation that then turns into solutions to problems that a lot of people face. So hats
You
off.
guys want to know something crazy?
You crossed
I
paths
just-
with Cody.
I just went on a walk with him 2 days ago.
Oh,
No
okay,
way.
all right.
Yeah, he's one of my best friends. He's a absolutely fantastic
Oh,
guy.
man. You guys
Of
can't
course.
make this shit up. It's like, you read a book about it or a movie, and so you can't believe it, right? Yeah.
We were roommates
brilliant.
at MIT. We were also lab mates at MIT, and he's one of my best friends from MIT. Amazing
Okay.
Why
guy.
does that not surprise me? Why does that
It
not
doesn't
surprise
surprise
me at
me.
all?
And I'm gonna get I want to option the movie script for this. I want to do it when you guys sell both of your companies for billions of dollars or merge them or whatever. I'm gonna option that movie script, and
Just
it's gonna be
FYI, Curtis, Vishnu talks about writing blog posts and he hasn't
Yeah,
gotten
that's
around to
true.
doing it. So optioning scripts, I mean, that is
It's a
now.
lot. It's a lot.
We'll see. Well, I'll believe it when I see it. But anyway, you were talking about how you saw through to this, like you had the vision and then basically what
A
happened
framework.
from over those last 6 years. Yeah. What
Yes.
did that look like?
Yeah, totally. And Vishnu, does that work for you too? I saw you looked ready
Yeah.
to
Let's
say
go.
something.
Let's
Okay.
go. Let's hear it. Your
Awesome.
story, your take on the last 6 years, and how you went from people cheating at Harvard on this test and noisy labels to where you are now.
I like how you said people cheating at Harvard. They also
my
cheated
bad.
elsewhere, but I don't mind how that was phrased. And I say
My
that as someone with MIT roots. We're always having a good time at each other down the street. There are lots of great people at both places. But anyway, so the first problem was, how do you detect false negatives in data? So that's something called PU learning. And that stands for positive unlabeled learning. And what the idea of that is, you have data, and some of it is positively labeled. So call that someone, say in a cheating detection data set, that would be someone who cheated. So you know for sure somebody is a positive, but you don't know for sure that someone didn't cheat. And that's actually, if you think about our judicial system, that's how it works, right? If you're on the stand, you're assumed innocent until proven guilty. The idea is that you never know for sure that someone didn't do something. So we can't assume that they did something. We assume that they didn't do something. And that's actually, if you think about it, a very logical reason for why we assume innocence until guilt. You have to provide enough proof to substantiate that someone is indeed guilty. And so you can only do that in one direction. And the idea of that is you never really truly have the labels of innocence, which is kind of an interesting thing to think about, especially for people who work in machine learning in the legal space. It's very difficult to train a machine learning algorithm to know if someone's guilty or not. That's why we haven't replaced judges, and it's unlikely that we replace the Supreme Court with AI anytime soon. And this is a very logical explanation for why that's difficult. But given that, so the first thing that we did is we had to solve this Pew learning problem. And that requires estimating a single noise rate. What is the probability of a false negative? And that's just one noise rate. There's another noise rate, the probability of a false positive. And so we then generalized our solution there to the full binary case of identifying false negatives and false positives, just for binary multi-classification. And I presented some of that stuff at UI. The paper's called Rank Pruning, and you can check it out. It's pretty theoretical. It was early days of grad school, and I had to, go pretty deep in the math, but I think it's well formulated for people who are in the field. Then it was a similar time to that when I went to Facebook, and I was working in Jan LeCun's group. Folks might recognize him. I saw him like 4 times total. I barely worked with him. I think on paper he was my manager, but my real manager was Elon Burrow, an absolutely fantastic person. In the early days, she was one of the first female research scientists at FAIR. And this is Facebook AI research, not Facebook engineering. And we were in the New York office, and they had a really interesting problem. The problem was, how do you avoid bias in up and down votes on comment rankings? So if you imagine that Donald Trump posts something that's, highly offensive, but because you're affiliated with a similar political, you say you're Republican, you might want to upvote it just because you want to support your party, which is a very reasonable thing to do. Even though the actual content of the message might be offensive. So that's an issue, right? Because now you have people who are upvoting content that's actually not content that they would upvote if not for some bias. And so what we ended up doing is thinking of it almost as a label error, right? So how do you detect these sort of biases? And I started to realize whoa, I mean, this is what I'm doing in cheating detection, but now we have a gigantic corporation that needs to do this on petabytes of data, literally trillions of data points at scale, and there's no solution for this. So what did they do? They hired an MIT Ph.D. student to do an internship on it, right? And I was like, wait a minute, this is what I'm doing, as my Ph.D., but this is clearly a problem that needs to be solved. Well, the next summer, I ended up going to Amazon, and I did the exact same thing. At Amazon, they had an issue with the Alexa devices where they have no idea when they wake up or when they don't wake up. So how would you know, for example, if you're Amazon, and you've got your Alexa devices all over the world, hundreds of millions of them, and people are saying, the keyword to get it to wake up, and they just don't wake up because they don't hear the keyword, then how would you ever get that data? Amazon doesn't have that data. They don't have it. So how do they know what their device's false negative rates are? They have no way to estimate that. And so does the problem make sense?
It makes total sense. And I'm just literally sitting there being like, that literally sounds like an impossible problem because there's no way you know something didn't wake up because there's no way you'd get the log from the device. So how do you do that? Is it just through user testing? What do you do?
We solved that problem using Cleanlab. So this was very early days of Cleanlab. And at this point, I had started building out the open source repo. Fun fact, the only reason why I originally did Cleanlab is open source. I think open source is a great model. And obviously, I have a business around it. So I clearly really love open source. I think it's a good idea. But the initial reason I got into open source was not because I was a super open source guru. I actually knew very little about it at the time. I got into it because people didn't believe that you could actually just have data find errors in itself. The idea of that seemed like black magic to people. So how do you convince people? You make it runnable in one line of code online. And then people start to believe you. You see, that's
Yeah.
why I did it. Literally, people were just like, "What is this nonsense? Like, I've never heard of this. It's a new field. How are you just going to invent a new field as a grad student? Like, that's total nonsense." And I got a lot of pushback, and so we started just releasing everything online. And then the pushback, quieted, and we got a lot different reaction. So the reason I share that is because I'm building out this open source package. Meanwhile, I was doing an internship at Amazon, and the open source package, what it did is it estimated these noise rates that I mentioned earlier, right? So it estimates false positive and false negative rate. And specifically what that is it's you have data and it's labeled a 0, but it actually should have been labeled a 1. Or you have data that's labeled a 1, but it should have been labeled a 0. And one thing that we do, at Cleanlab is we tell you what's the fraction of data, and we do that by estimating this joint matrix of noisy labels and true labels. And that's just going to be, if it's binary, a 2D matrix. And then, the off diagonals of that will be the flipping rates, and the diagonal of that matrix will be sort of your consistency rates, which are like the things that are labeled 1 and they actually should be, and then the things that are labeled 0 and should be. So that's kind of hard in an audio, environment to see it. But just imagine you got a 2D matrix in your head and you're trying to estimate those off diagonals because that's your noise rates, your false negative, false positive. Okay, so to the Amazon problem. So at Amazon, what they don't have and they need to estimate is they need to estimate the probability that something was labeled a 0, but it should have been a 1. Okay, so
Wait,
the
so real
device
quick.
got it.
Real quick. So you just said there consistency rate and flipping rate, right? And that's the way to think about a noisy data set is like those two factors, let's say adding up to 1 or something like that, in just like the loosest way to think about it, right? And what you were trying to do with those with the Alexa examples is try to estimate like what's the actual flipping rate of the data being wrong. Is that correct?
Yeah, totally. And the only caveat to what you said is that in this matrix, the whole matrix sums to 1. So it's like a joint distribution. And then if just a fun fact of how to think about the problem, if the diagonal of that matrix sums to 1, then you have no error at all in your data.
Got
Meaning that all the off diagonals are 0, which means all the noise rates are 0, which means nothing's flipped. So no error in your data.
Got it. Okay, interesting.
And another thing to keep in mind is that this is only one formulation of the problem. We do several, and I've spent time on several. This formulation is one called class conditional noise, and it assumes that any class can be flipped to any other class at some set constant rate, and you're trying to estimate that constant rate. And that's really useful because like the probability of if say you have an image data set of a bathtub being flipped to a lion is very low. Like you're not going to have many images that are images of bathtubs with the label lion. That's really unlikely. But it is very likely that you have images that are labeled tub. There's all sorts of tubs. There's like buckets. That's a tub. But it might be labeled bathtub or vice versa. Or a lion might be mislabeled as tiger. That's highly likely, but it's highly unlikely that microphone is mislabeled as vegetable or something. And so you can see how these flipping rates emerge.
Yeah, that makes
and then
perfect sense.
Yeah, and there's also like all sorts of other noise where you have it's called instance dependent. So that would mean depending on the image, so say you had an image and it has a very cat-like dog, then because it's a cat-like dog, you would say what the probability of it being mislabeled as cat, even though it's a dog. And that's another approach. And then there's also just noise in the data that has nothing to do with the labels, like out of distribution, all stuff we do. But let's focus on the solution for Amazon. So the way that we were able to approach that, yeah. And by the way, one of the reasons we couldn't publish this is it's kind of funny. It's really hard to convince a massive company to publish its noise rate in a a device that's sold to hundreds of millions of people. To openly publish.
Yeah.
No, it's not great. So it's not easy to convince administration to say, hey, yeah, let's publicly share how wrong our devices are. But here's how we estimate the noise rate. We use Cleanlab to find one of the diagonals, okay? And then we also use Cleanlab. If you can find errors with something, you can also find good data with something. There's always some ranking metric. So what we do is we can find a quality score for every example, and then you can find the examples that are high quality. And that gives you an idea of out of the things that are labeled 1 and the things that are labeled 0, what fraction of those are likely labeled correctly as well. And so now you have 3 numbers. You have the false positive rate, the true positive rate, the true negative rate, and that's all you need to compute the last one, which is the false negative rate. So if you have three things that you can estimate because you can observe them, and in total that matrix sums to 1, then you can always estimate the fourth. And so that's how you can estimate something that you actually just don't have, because you know all the other cases of how the model performs on the data. And so even without the data, you can estimate how the model would have performed. And that's kind of brilliant. And so that was the approach that we took. We just couldn't share how bad things performed publicly. That was the downside of the research.
So just so I understand, because this is kind of blowing my mind here right now, and I'm sure it's blowing the mind of a lot of our listeners right now. I don't know about you, Demetrios, but you're saying that when you talk about doing it in one line of code, right? I want to go to that example right there. Or now that you've been working on Cleanlab, and maybe this is a clean transition, clean. If I have, let's say I have, a data set that I've worked with, which is chest X-rays, right? And the chest X-ray data set 2014 from the NIH, it's filled with data errors, right? And I had trained a machine learning model on it. And there are a couple classes in there for different diseases. And, let's say it's pneumonia and some other lung disease. And I have some results where I've trained the model, and I want to use Cleanlab in this example. How can Cleanlab know, just based on the model's performance, that particular examples are more likely to be, falsely labeled or incorrectly labeled? Like, can you walk me through how Cleanlab implements that?
Yeah, totally. And this is a good thing about having a company that's half open source, half SaaS product, is that I can share things. And that was pretty necessary for us. We have three co-founders out of MIT. We all did our PhDs there. And we care a lot about being able to educate and share. So part of the idea of founding a company that has roots in open source is it gives us the ability to just talk and answer questions like this. Instead of most CEOs in this position would have to give you some kind of, and I truly don't mean this in an offensive way, they have to do their job, but they would give you a BS answer. They wouldn't actually tell you how their product works, right? That's terrifying, but we can actually do that. And so here's so I'll just share. So very briefly, one insight, there's obviously more advanced things that we do in the SaaS product, and I'll leave those where they lie. But here's a really simple intuition. You have a model, and it has produced a predicted probability, okay? You've trained on your data set, and now you're going to run an inference pass on a new example. You have some new example, some test set or something, or some held out data. And you run your model on, it's been trained on your training data, which has noise in it, by the way. And now you run a new example through it, and that example is a mislabeled example. So you have a real label for it. It's held out data. So you actually have labels. Don't think of it as test data. You do have labels for this. And it's held out. And now you run you run an example through your model that's been trained on your noisy data set, and it produces a probability distribution. And the probability, let's say that it says let's say the thing is labeled dog, but it says like with 1.0 confidence, okay? So it's like a softmax with, literally all of the weight on cat, okay? Then in your head, you might just be thinking like, that seems surprising, right? Like this thing I have a label for it, and the label's dog, and I threw it into my model, and my model spit out 100% probability of being cat. Like if this model learned anything at all, then something is amiss. And so that's just like a really easy way to think about how you might find an error. Like literally, that seems pretty like one line of code, right? You just did an inference pass, and then you just measure, is the probability of the given label like way off, Is it way different than the probability of the argmax? So that's one way you can think about it. The question is, and this is where it gets more complicated, how do you know what the threshold is? And what I mean specifically is, okay, what if it's 0.5 dog, 0.5 cat? What if it's 0.3 cat, 0.7 dog? Like how do you know the threshold? And so there's a lot of approaches to that and a lot of smart things you can do. One way is you just can look at, random, the 90th percentile of all your cat examples. Another way is to take the mean. Another way is to take an approach that's entirely different and like fully model the entire joint distribution. And then you can, sum up the diagonals and do all sorts of fancy stuff. But that just gives you like a really clear idea. You have a data set, you can pass it through a model that's been trained on it, and then you can take the, whatever the probabilities are and say, hey, look, this thing is labeled dog, but like the probability of dog is really low and the probability of cat is really high. It might be a cat. And that's just an easy way to think about finding label errors with a model.
I see. So it's looking So it's really looking at where models make mistakes and using that to understand what that false positive, false negative rate is. Is that a fair
Yeah,
summary?
almost. It's a super fair summary, but there's one really important caveat. It's not just where models make mistakes. This is the model centric point of view. It's also where the data make mistakes, where the data made mistakes. And the way that you can think about this in the model is embedded two things. One is noise because the model's not good enough. And the way you can think about that noise is it's noise where if you had perfect data and you trained the model, you still wouldn't get 100% accuracy on all test data. If you did, that would be incredible for your problem and great for you. You've just, you have a business and you should probably build that. But in general, most people don't get 100% test accuracy. And so whatever the noise is, right? So say you get 95%, then your model has like 5% inherent, there are words for this. Aleatoric, if you've heard of aleatoric and epistemic uncertainties. Aleatoric is like label noise and epistemic is like model noise. So this is epistemic. This is intrinsic noise in the model. But then there's also noise from your data. So things that are mislabeled and bad data. And the model's going to learn that too. You trained on that data, it's going to learn that noise. So if say 5% of your cat examples are mislabeled as dog, then that means that when your model is producing predictions, 5% of if it's a good model, 5% of the time it's going to produce wrong predictions. It's going to produce the wrong label for those dog examples. And so you can literally think of it that way. Your model's making mistakes on its own intrinsically. That's called epistemic uncertainty, epistemic noise. And it also is modeling, because it's trained on noisy data, it inherently models that too. It models the noise as well. So and that's called epistemic uncertainty. Now the kicker, the trick, is you have to disambiguate epistemic and aleatoric uncertainty out of one single model. And you cannot do that without assumptions, because a model's prediction, it's literally just making a prediction. So you have to make some assumption and then use that assumption to disambiguate. And if you remember earlier, I talked about a matrix where you look at the flipping rates of every class to every other class. That's an assumption. And you can use that assumption then to fully solve this problem and fully characterize label noise. We also make some other assumptions, like out of distribution assumptions. And also you can do instance-based assumptions where you say like there are groups of error. You can go crazy here. Too crazy for a podcast, but you get the idea.
No, that's a brilliant extra explanation of where I may have glossed over the crucial detail. And I love that point about the difference between epistemic and aleatoric uncertainty. That really helped me understand what it is, what conceptually you're trying to do. And now I understand what makes Cleanlab particularly powerful is that you've embedded a lot of the ways of working with these concepts into code so that people can start to do this with their models and their data. And by making it open source, the code can get even better, right? And people can contribute and help you guys expand your functionality. Is that a fair thing to say?
Yeah, for sure.
Okay,
Yeah,
cool.
I'm
That's
curious
definitely the idea.
as
Yeah.
to
That's
just
awesome.
what it looks like. And can you just break it down? Like, what do we have? Is it some kind of Python wrapper, or is it something I need to install? How does it actually play with my environment?
Yeah, for sure. So you have some data set. It can be represented however, it doesn't matter. So here's some fun facts. So Cleanlab works with any model and it works with any data as long as you can run a model on it. So as long as it's like ML data, let's say. So it works with any ML data and then it works with any model. And that's cool, right? So that means if we so right now transformers are hot. LSTMs were hot 10 years ago. So if you built a whole company around LSTMs, your company might be in a really bad spot, in 2020 if you built it in 2010. And so it's the same idea, right? You don't want to. So we built a company around this. We don't want to be in a bad spot in 2030. And so one way we can guarantee that is by building a company that works no matter what the model is that's invented in the future. So if something much better than transformers comes out, we want to make sure we work with that too. And so the way that we do that is we work with the outputs of a model, but we don't care which model generated them. It's just different than a Markovian assumption, but you can think of it like a Markovian assumption. We don't care where it came from. We only care about the now. What are the model's predictions? It doesn't matter what the model is, and it doesn't even matter what the data is. In reality, there's actually a lot of data, like very specific data assumptions, and different data distributions are totally different, and there's all sorts of weird stuff that happens. But if you have an appropriate model for that data set, you can abstract that away, make it more of an engineering problem and less of a theoretical problem, and just take those model outputs. Okay, so to answer your question concretely, now you have these model outputs, they're predicted probabilities, and you have your labels, some noisy labels, and then you're going to input those two things into one line of code, and it's going to spit out things for you like what are all the label issues, in that data set, or it'll spit out. We do a bunch of stuff. There's a package called Clean Learning. So this is kind of cute. If you do machine learning, but you want it to be clean, right? You want it to train on cleaned data, machine learning with cleaned data. We call it Clean Learning, and it's a class, and you can actually just pass in like a sklearn model directly into that class and pass in your data, and it will just work. Or you can use the functions directly, where you can just pass in like your model outputs, and that way you can work with any model at all. But yeah, that's mainly how it works.
I love that summary. I think that was a great question, Dimitrios, because it got us to the nitty-gritty of what it actually feels like, which is so important with, I think, tooling right now in machine learning, right? This stuff is moving very quickly. The fact that you're talking about the concepts that you are around how to think about data feel very different than the way that we taught about data and modeling like 5 years ago, right? And with the speed at which things move, having tools that feel easy and work well with your existing workflow without too much I guess you could say friction is really important. And it certainly sounds like Cleanlab is that way. I think one of the questions I had coming out of this is, as you can probably tell, I've worked a lot in the medical context, right, where noisy errors are both incredibly costly and incredibly common, right? Noisily labeled data sets, you have a lot of variance in the way that medical professionals are trained. And on this data quality problem, I kind of have a question around like how ML engineers should think about it. And my question is this something that can be just solved by a tool or a framework or some kind of, new widget like Cleanlab, not necessarily to denigrate it, but just like a tool like that? Or is this something that you think ML engineers should take more of a systems level approach to and kind of say like, hey, the same way that you think about like, web systems architecture or something like that in a different software engineering field, machine learning engineers should start to specialize in thinking about clean machine learning systems. Let me know if that question made sense, because it's just
Makes perfect sense.
Okay, cool. Yeah.
It makes so much sense that our entire business model is the answer to your question.
All right, well, hit me.
Oh, nice.
Yeah. So let's start. Here's a good thing to think about. If somebody says that they have built something that works 100, it does everything. We do a lot of things automatically. So we can find label issues for you automatically. It's pretty cool. And we can even provide suggestions for solutions automatically. But that's not where it ends. It's not just 100% everything automatic. You press one button and that's it. You're done. If you have someone, whether they're academic or they're in business or they're an entrepreneur, and they say, I have built an AI solution and it just does everything and no human ever needs to be involved. Well, then the question is, why are you involved? Right? Why don't you just let the AI run off and, and just do everything all on its own? Like, why do you even need to be involved? The reality is there are very few AI solutions that don't still require some kind of human input. Like if you look at, DALL-E, it's incredible. It's really incredible. GPT-3, it's incredible. But also, why do they need a team of like 150 people to build those things? That's where the human is involved. So it's not like these things are building themselves, or they're just like, and now there's even bigger teams that are working on these things because they've been shown to have viable business model. So there's always a human in the loop. So that's just the most important thing to remember. It's easy to forget. These models are doing a lot of really cool things. I think there was like some article yesterday about somebody who was working at Meta or something, and they accidentally created, you know what I'm talking about, Vishnu?
Is it the guy where the Google engineer was saying that the AI is sentient? Is that the one you're talking about?
Yeah. He was like,
yeah.
Yeah.
yeah, and he like got fired or quit his job or something terrible happened because of this.
Yeah.
But he was like, oh no, I'm working with an AI and it's sentient, and everyone's like, this is a lot.
Yeah. I know exactly what you're talking about. Right.
Yeah, and I think what we can create, we eventually can create things that give the appearance of sentience, and maybe even indistinguishably. But just keep in mind that it was created by a person, and that person created constraints. And the more you constrain something, the easier it is to make it appear sentient within the context of those constraints. And that's just kind of a rule of thumb. Okay, so with that in mind, so to answer your question, so your question is about, you know, can you just have something like Cleanlab just, you know, fix everything and then it ends there? And so that's really important to think about. So what the open source does is it's prescriptive. Okay, just like a doctor, it tells you, but it doesn't make it all go away. You know, it tells you, hey, you need to take this medicine, you need to do this, but it doesn't like take the medicine for your data. Okay, so it'll tell you what the issues are, it'll tell you the quality of your data set. It's really helpful, but it's just prescriptive. It doesn't change the data set. If you want something that will automatically fix your entire data set for you with one button click, good luck, but we'll get you really close. Okay, so we have something called Cleanlab Studio. That's our SaaS product. It builds on top of the open source, adds a bunch of fancy infrastructure, trains the model for you, and makes it so that it's a no-code solution. Now, I just sound like, you know, a CEO pitching, but like, check it out. It's actually really awesome. But here's why it's useful and why it answers your question. What it does is it also helps you fix the data set, whereas the open source helps you find. So the open source is prescriptive, and then our whole SaaS business model is like, hey, people have seen that Cleanlab works, but now they want to, you know, very quickly and easily be able to actually just fix the whole data set, not just know what's wrong with it. And so to do that, you do need a human in the loop. You need someone to take a look. We provide suggestions of what we think all the corrections are, and we have an AI and it runs and it checks and it guesses, okay, this is what I think all the true labels are. Here's what all the errors are. All the data is ranked, and we do all this for you automatically, and that's really cool. But we still suggest, you know, you should have someone take a look. And so one of the ways that we help you is we take data-centric AI approaches to make things more human-centric. And so the way that works is if you know which data point is the most likely to be a problem, then you want to show that to a person first so you don't waste their time. And then you can know the second most likely problem and you show that to a person second. And so the cool thing that our SaaS product does is it lets you very quickly go through only the most important stuff that might be wrong with your data set. And we also will give you an idea of what we think the right answer, so you do as little work as possible. And that answers your question. The question being, you know, do we still need people to be involved? And the answer is, you know, definitely, if you want the highest quality for many solutions. And that's an example of how you can use data-centric AI and data-centric approaches so that when you do involve people, you make it as easy as you can for them. They still should be involved, but what we can do is use smart methods to make it so that you only spend, like, you know, an hour cleaning a data set that normally would have taken 10,000 hours. And that's the goal, and that's what we do.
Brilliant. So there's something that you said when it comes to quantum computing, and how one of the investors or one of Cleanlab's advisors and investors is dealing with quantum computing. What does that have to do with anything?
Yeah, totally. So I will just rephrase. And when you say dealing with quantum computing, we're talking about Ike. He's known as Ike, but formerly Isaac Chuang. And he was the first person to realize, meaning to actually have a physical on-Earth manifestation, to build the first quantum computer. So this guy built the first working quantum computer. Single
so
qubit.
Not just dealing with it. He's the guy behind quantum computing.
It's fair to say he invented the first realization of a quantum computer on planet Earth. And there were a few groups doing it simultaneously, and so let's give credit to everybody. But he was one of those groups, and maybe this is they're all within a week, but he's credited that way, and rightly so. He's been doing really top-notch research in quantum computing at MIT for the last 20 years. He also wrote the book on quantum computing, Isaac Chuang. If you just look him up, you'll figure that out pretty quickly. So why is that relevant? And this is really cool. So the way it's relevant is the approach in particular that was used is something called NMR, quantum computing. And we don't have to get into the details, but the way that you do quantum computing is you have noisy information, and then you're trying to do some sort of computation on it where you are basically inferring what is the true signal from some noisy, non-binary 0-1 signal where you have to observe something, hit it with a laser, and then there's a lot of error in that process. And so one of the key solutions, and if you just look up NMR computing, quantum computing online, and you'll see that the biggest problem actually with the field is as you have more qubits, it's harder and harder to understand what is the noise and what are you interpreting versus what's the reality of what's happening on the machine. And so the way that you solve this is you estimate what's called a noisy channel. The noisy channel is what perturbs the actual computation to what you observe. And if you can estimate the noisy channel, then you can see, okay, what did I observe? And then I can use the noisy channel and I can actually reverse engineer and find out what really was the computation that happened. And that's how you do quantum computing. That's like the key to being able to do quantum computing is you have to actually be able to understand what's really happening versus what you observe and observability. Okay, so this
I
all
see
sounds
where
like
this is
crazy,
going.
You see where it's going. All right. So it sounds like, just a little bit wild at first, but then, here's where it's going. So we said, all right, let's take the whole model of how quantum computing is done and let's apply it to a data set. A data set has what you observe. That's just the data, right? You observe that data. But the real question is, what would the data have been if it didn't have out of distribution examples, if it didn't have label errors, if it didn't have all this noise that's causing you to not be able to train your model well, right? And so that's the question. And so what we do is we compute that same noisy channel and we have our observation of the data and we can use that noisy channel, meaning what was the noise process that created this noisy data to uncover what the true data was. And then you train on that true stuff. And that's how you get like a better model, or that's how you find out which of your annotators is making the most mistakes or whatever you want to do. And that's how it works. So you can actually use the same ideas from information theory in order to solve this data problem. And me and Ike worked together to invent what's called confident learning, which was this field that underlies Cleanlab. And we worked on at MIT together on this for about 6 years.
I guess the question that I wanted to ask after that is, going back to where you're talking about Alexa and the work that you were doing at Amazon and Facebook, like this work around confident learning, what was the result that made you realize that you really had something that worked, right? Like I'm kind
Totally.
of curious what your aha moment was there.
Yeah, there were a few. So there were stepping stones. I thought I would be faculty. I was doing a PhD. We were building a new field. It was really cool. I had some good contacts at the Media Lab that, likely would have been fruitful, or let's say may have been fruitful. And I thought that would be a cool thing to do in the next step of my life. I had some really good friends who I had been working with along the way. Jonas Mueller and Anish Athalieh, who I'd been publishing papers with. We were nominated for the best paper at NeurIPS for our work with Cleanlab. If you go to labelerrors.com, you'll see the 10 most commonly cited machine learning data sets, and actually the test sets that we benchmark on, and there are all the errors in them. And this is groundbreaking because now you could actually see that all the test sets of the field of machine learning that we benchmark on, they're all broken. And so basically we had a lot of results, a lot of excitement. So why did we choose to do a business? And what was sort of the key stepping stones that convinced us we really need to do this? This is a viable business and it's a good idea. So I'm rephrasing your question, but that's because it sets me up. And it sets me up for the answer. And so the answer is, at first I'm at MIT and I'm building this cheating detection system. And I realized, damn, the only way I can do this is to fix the data set, because I don't even know like any of my false negatives. I have tons of them. And how do I estimate those? So then I'm like, okay, if I want to build an AI ML solution that like really helps people, I have to do this confident learning thing. I have to have something like Cleanlab. So then I'm like, okay, Cleanlab seems pretty useful. Well, then I went to Facebook and I was like, oh, okay, now we're doing the same thing on petabytes of data, like literally trillions of data points. And Cleanlab is really useful. And then but still, like I didn't think of it as a business because I was so focused on the problems. And then I was in the theory, I was a grad student, my head was down, I got to get a PhD. Then after that, I went to Amazon and I mentioned that use case. After Amazon, I went to Oculus Research. I spent 2.5 years with Oculus Research part-time. I worked with Richard Newcomb, who's the director of science for I guess now whatever Meta's new version is of Oculus Research, and it keeps changing. But Richard Newcomb is a fantastic guy. He was one of the creators of SLAM in terms of making SLAM operational and useful generally. He made a startup that was then acquired by Oculus, and that's how he became director. He's like this British guy, super fun, super smart guy, awesome to work with, bikes like 100 miles a week. Just a really cool guy. And I worked with him for 2.5 years, and that was it was pretty instructive in my career and seeing how does someone direct a very large AI team, not just being on the researcher, but how do you build these things, and how do you build a team? And that was helpful and pivotal for me. Pivotal for me. Then what did we do there? We used Cleanlab to be able to clean and create some of their data sets. And so I was like, what? This is really useful again now for Oculus. Well, the next summer I went to Google. And this is when I started to really realize, okay, this needs to be a business. At this point, Cleanlab open source was getting pretty fleshed out. It was useful. You could run things in one line of code. And I ended up implementing a version of Cleanlab, a simpler version inside of Google. And if anybody works at Google and they're listening to this, you can still see it. It's at /Google3/third-party/Cleanlab. And and we use this at Google to fix the OK Google and Hey Google datasets. So if you've ever said that to an Android device, the way that's how we clean that data set. Yeah, use Cleanlab. And so then I'm like, wait a minute. So that's another gigantic data set across like 50 million examples. And then we got some testimonials from Google. Some of their engineers, they sent us testimonials and they were like, hey, if you guys, have a company around this, like here's a successful pilot. Meanwhile, we got some reach out from other companies in the labeling space saying, hey, would you like to join our team? Can we acquire this thing? And I'm starting to realize, okay, there are people paying attention, and not just from an academic perspective. This is a problem that pretty much every major tech industry needs to solve. If you don't know, $3 trillion is the estimated cost of the US alone of bad data. And we have a tool that we have shown and benchmarked outperforms other tools to find bad data. And so it's like, well, this is a gigantic market, and we have a solution for that market. And then more and more people started reaching out. And then we had the team that was happening organically from the research at MIT. And then we had a best paper nomination at NeurIPS, which brought more folks. And then we did well in the data-centric AI competition. And there was more momentum. And then it was something I actually could not do. And I was doing another startup. It was a really cool startup. It used Cleanlab to clean emotion data so that you could train an emotion detection algorithm. And that way, if you're doing like a sales call or a hiring call, you could actually say, what's the metadata for every frame in terms of their emotions. That's really useful for doing sales. It's extremely useful. But it's very hard to train because emotion data is noisy. So we use Cleanlab for that. And then I was like, why am I building a startup that uses Cleanlab? Cleanlab is the startup. And that was sort of the final pivotal transition. Yeah, that was the plot twist. Yeah.
Dude, so
but that's
one thing go ahead. Was there something you wanted to finish with?
It's the final. I was gonna do like a J.R. Tolkien final sentence. That was how it came to be.
So one thing that stands out to me though in all of the history of Cleanlab is you've been working with huge companies. I mean, the biggest companies around, right? Especially in tech. Does this still have as much utility for the small data sets as it does for the Googles and the Amazons?
Yeah, it works for any data set. So it's the reason why we wanted to work with big companies from the start is because nobody else could do that. And so if you're building something, if you're entering a market, it's a good idea to say like, what can you do that other people can't do? If you look right now, if you just search online, data quality for AI, it's like 100 companies. Like everyone is branding themselves data quality for AI. But show me a company that does label quality. And it's just like not a thing. Well, that's what we do at Cleanlab. Well, show me a company that can do label quality for data that's already been labeled at massive scale. Like that, these aren't keywords that you see as often. And so we realized that was a differentiator for us. And so we wanted to work with key pilots where we were fixing labels specifically. We can also do tons of stuff in the data space, out of distribution examples, but we wanted to focus on something that differentiates us and something where we do extremely well, where we know we have one of the best solutions. And that was just the main reason, but it works for any data set.
So you've inevitably had to have seen some really exciting things happen since Cleanlab launched, I guess. What are some huge success stories or just things that you didn't think were possible that potentially became possible, or things that you stay with you because it's been so astounding?
That's a good question. I would say the whole journey, in a sense, is feels that way. If you just I take a big bird's eye view for questions like this. So I just think about where were we 10 years ago. So when I was sitting in 2016, I'm an intern. I'm a very green-eyed, excited intern. I'm like 20, 24, 25 or something at this time, and I'm sitting inside of an office room with Jeff Hinton and Jan LeCun and some other Facebook AI researchers. And I really didn't even realize at the time just how much of an experience that was, because I was pretty young and I'd read a few papers, but I didn't know, like, these are some of the biggest minds of our time. I didn't know they were about to win the Turing Award or the Nobel Prize for Computer Science. And so this is the experience I was in. And then Jeff Hinton, he shared with us one label error. Okay, so we're at 2016, just to give you an idea of the time and space. And he shared with us one label error in Jan LeCun's data set. And he was genuinely excited about that. A, because he's, proving a friend, that they're friends. And he's like, hey, haha, I found an error in your data set. But also B, I think that's just representative. If you have one of the greatest minds of our time in our field who's excited about one error in a data set, and now we're finding, millions of these things at scale, and we can do them generally. That is exciting. When I just take a bird's eye view and I'm like, okay, we've built now a business around this that actually does this at scale for anybody. And if you just go to labelerrors.com, you can literally see millions of them, many of them in the same data set that Jeff Hinton was finding an error in. That's pretty cool.
Hell yeah. Oh, that's incredible. Well, I want to end with some rapid fire questions for you, if you don't mind.
Sure.
First one is, what was the last book you read?
Last book I read was The Bazaar and the Cathedral, which is it's an open source book. It's from some of the original folks who created, if you know, Linus Torvald, who created Linux. And it's the perspective of why open source as a business can be a good model. We do both SaaS and open source, but it's a pretty cool book, and I highly recommend it for anyone who's interested in open source.
Okay, I like that. And as a big fan of open source, I'm going to have to check that out. Next one I've got for you is, what was the last bug that you smashed? I know you were up late last night. Was that smashing bugs, or
no
that
bug
for something
smashing? We had some good opportunities, and they were good enough I wanted to stay up for them. But let me think. The last bug I smashed. Last night so I'm in California. Sometimes you'll open the door and there'll be some flies that come in, and it was a nice day. And there was this fly, it kept buzzing around. You know that experience? You're like trying to do your work and there's some fly buzzing. It doesn't matter where you are. You can be in a penthouse or you can be in, a tent somewhere. There's always going to be flies, and it's one thing that unites us. No matter what your position in life, everyone has to deal with flies. So I totally smashed that fly.
All right, I like you took that one a little bit different direction than I was expecting, but I like it. So you, as a business owner that is selling into the ML space, what is a piece of ML marketing or MLOps marketing, ML tooling marketing that you have thought about putting out, or your team has thought about putting out, or you've seen put out that made your eyes roll?
Roll like this is like, so, I mean, I think I already mentioned it, but when I see just data quality for AI, just in general, we even use that sometimes at Cleanlab. Like, I think if my current banner on LinkedIn says data and label quality for AI, but then we put automated around it just to emphasize what we do differently. But in general, I don't like that phrasing. It's just that people have gotten used to it. But I think it's so generic. And if we're all saying the same thing, how does anyone know what anyone's doing? So when I see that, it kind of makes my eyes roll, because there's no differentiator, and it's just like, what exactly are you talking about?
Dude, I think that's one of the biggest problems right now in this space, is that so many of the tooling companies are saying the same thing, but taking drastically different approaches to getting it done. It's like, oh, the outcome is the same, and so that's what we're pitching you, the because I think all the marketers on the teams are like, they've gone through the, what is it, the things to be done marketing school, where it's just like, no, you don't want a hammer and a nail, you want a picture on your wall. And so we're pitching you the picture on the wall, not the hammer and nail that gets you that picture on the wall, right? So the idea here, when people say, oh yeah, we make your ML faster, or we give your data quality assurance and that kind of stuff, it's like, yeah, but how? And then it just creates a very cloudy and mystified space. And people have to really search around and dig really hard to see if what the tool that they're looking at does what they're looking for, and if it does it in the way that they need it to be done. And so I'm fully
Totally.
on board with what you're talking about there, like 100%. Now,
Yeah,
this next one, did you have anything there? Sorry.
I would just
cut
say
you off.
the biggest, no, it's okay. I just think the biggest detriment for the field, and I mean in industry, like for businesses and ML and AI companies, is that there are probably 90% of them are companies that claim to use AI, and there's no real clear explanation of what is the AI. And then you find out that they've downloaded a PyTorch model or a Hugging Face model, and they're running it through a generic SageMaker tool that's already been set up for them, and that's the total sum of their AI. It's just a black box tool that anybody else could download for free. And when you find that out, and then it's called an AI company, I just, it's not necessarily a bad thing. Like people will do business where they do business, and not all business has to like come out of fundamental research, out of a university. It's okay. It's just that it's confusing for users and for customers what exactly the value is that they're paying for. They don't know that they're paying for its potential, that some companies, they're just paying for something they could download online, and that's not made aware or clear to them. I think that's a problem from a business perspective and from an honesty perspective with customers and users. If you're going to be an AI company, ideally, and this is not the world we live in, but in an ideal world, you would be paying for innovations in AI, and that's why you're actually paying for something. But and that would also drive innovation in AI, which would be good for the world. But we don't live in an ideal world. We live in a capitalist one.
We do. And it's cutthroat out there. There's sharks out there, so they got to eat.
Yeah.
Last one. Well, what piece of technology are you bullish on that might surprise people besides Cleanlab? Obviously, that wouldn't surprise anybody, I don't think.
Yeah, I'm bullish on a lot of things. I think long term, I am pretty bullish on quantum, but I think it'll take longer. For like the last 30 years, they've been saying 10 years, right?
Yeah.
So, but I've seen the work that's done internally, and I think that it will be fruitful when combined with a classical computer. I'll just leave it at that because I think I can tell you've got another question.
Damn, that leaves me wanting to know so much more, but we'll save it for the next one. Last one is, Curtis, how do you want to be remembered?
I want to try to empower people. I don't actually mind how I get there, but one way is to build a business that makes AI work for real world human problems, and that's Cleanlab. I make some music, and I hope that helps people in its own way. I try to do a lot of stuff back home. I'm from Kentucky, and if you think about the field of ML and businesses, a lot of that, what's earned and the revenue and what's created by that and the opportunities tend to go to the cities, and not much of that usually goes back to places like Kentucky. So one thing I did is I hired our chief of staff, for example, from Kentucky, and she works remotely there, and just any way that you could sort of give back. So just in general, empowering people, creating opportunity. I tried to validate certificates in edX. We did that at scale. We ended up validating literally tens of millions of certificates. And I just want to keep doing stuff like this until the day I die. How do we use technology and the latest innovations and build new ones that can empower people at scale? That's what I'm here to do.
Incredible answer. Are you guys hiring?
Yeah, we're hiring. We filled most of our positions. We'll do another big hiring sprint next year. But if anybody's interested in DevRel, developer relations, that's a pretty awesome job because you can.
That is.
It's sick because you basically build your own profile. If you like social media, you can use the job to your advantage to build your own following while also helping us out. So we're hiring for that role, and also, some engineers. If you're a great front end engineer, reach out.
All those TikTokers out there, hit Curtis up. So sweet, man. This has been really cool. How many people did you catch cheating at edX? Do you have a number?
Yeah, so we gave a lower bound because it was published. So in academia, you have to, when you say something, you need to back it up, and
Yeah.
it needs to be falsifiable. But we said that it was a minimum of 1%. In some courses, it was much higher. It was as high as 10%. It's not true anymore. Now they're running lots of cheating detection algorithms. So I highly recommend that you don't cheat. You're probably going to get banned. But in the early days, you would have like 10% of people just blatantly cheating and not learning, which was really sad.
Yeah, that's a bummer. Dude, this has been so insightful. Thank you for coming on here and schooling us to all of this. And now I will never look at data-centric AI the same way again. I'm just going to come clean. I thought it was some marketing bullshit when we got on this call, and now I'm a little bit bought into it. And as long as I am able to reproduce what you said, maybe like 1/10 of the ability of what you were able to say it means, I think that I'm cool with saying data-centric AI and not feeling like cringeworthy afterwards.
Totally. Yeah, it's pretty useful stuff.
Sweet, man. Well, thanks again.